Hello guys, welcome to another video for our course. We are now in module 4 or chapter 4 of this course, and it is about differential equations. Okay, so differential equations is one of the most important application of calculus. So this is the time now that you are going to solve real life applications where we can find calculus. Okay, so also you will learn several methods and techniques in solving differential equations. So for this chapter, we are going to talk about the sketch of the slope field and the differential equation and find the particular solution of a certain differential equation. Also, we are going to discuss how to use an exponential function to model growth and decay, how to use separation of variables to solve differential equations, and how to solve a first order linear differential equations and the Bernoulli differential equation. So there are a lot of types of differential equations. One of them is the first order linear differential equation. We also have what we call homogeneous differential equations, partial differential equations, second order linear differential equations. So there are actually a lot of classifications about differential equations. Okay, so for this video, we are going to discuss the slope fields and the Euler's method. Okay, specifically about the use of initial conditions to find particular solutions of the differential equation and slope fields to approximate solutions of differential equations, and also use Euler's method to approximate solutions of a differential equation. So, as I recall, differential equations are equations in x and y, and it also involves the derivatives of y. So you can recall no uh, differential equations sa itong mga previous nga mga chapters before ani. Okay, so it involves the variables x and y, and also it involves the derivative of the variable y. Okay, so in the next section, you will see that problems involving radioactive decay, population growth, Newton's law of cooling, or can be formulated in terms of differential equations. So we can actually model these applications using differential equations. Okay, about the radioactive decay, about the population growth, or I think this is new to you, no? The Newton's law of cooling, kanang pagbugnaw sa a certain object. Okay, so a function y is called a solution of a differential equation if the equation is satisfied when y and its derivatives are replaced by f of x. So ang solution sa differential equation is a function. It is another function. For example, no, differentiation and substitution will show that y equals e raised to the power of negative 2x is a solution of this differential equation. Nga naman, because when you are going to take the derivative of negative of y raised to the power of negative 2x and then add it with 2y, you will obtain 0. Okay? Kaya ang mahitabuan na ron is we have y equals e raised to the power of 2x, and then this is a solution of the differential equation y prime plus 2y equals 0. So we know that the derivative of this is e raised to the power of negative 2x times negative 2, which is negative 2 e raised to the power of negative 2x. Okay, so therefore, from this differential equation, this one is negative 2 e raised to the power of negative 2x plus 2 times your y is this one, e raised to the power of negative 2x, and that is equal to 0. Okay, so this is negative 2 e raised to the power of negative 2x plus e raised to the power of negative equals 0. So 0 is equal to 0. So it is satisfied. Therefore, this function, this is a solution of the differential equation. Okay. So it can be shown that every solution of this differential equation is of this form. Okay, so this one, this y equals e raised to the power of negative 2x. This is what we call the particular solution. While this is also a solution of the general equation. And this is a general solution of this differential equation. So general because this function involves a lot of individual functions. So for a given value of c, you can obtain a specific or a particular solution of this differential equation. Okay, so some differential equations have singular solutions that cannot be written as special cases of the general solution. However, such solutions are not considered in this text. So we are going to specify only up to the general solution and the particular solution of this differential equation. Okay, another example, for instance, we have y equals 4y. So this is a first order differential equation. First order linear differential equation are discussed in. Okay, so this is a differential equation. Then this one, this is the second order differential equation as double prime. So as you can see, this is a double derivative. So second derivative is the original function. So ang question karon diri is, what is the original function that the second derivative is this one? Okay, so katong original nga function mo to siya ang solution sa kining general equation. And if maka-remember pa mo sa atong previous discussions, the original equation is given by this. S of t equals minus 16t squared plus c1t plus c2. Actually, we can show that the solution is this one by simply taking the integral of that differential equation. For example, we have s double prime t equals negative 32. So when you integrate this one, dt, you'll have negative integral negative 32 integral dt, which is equal to negative 32t plus c. So let's say c1 na siya. Okay, this is double prime, and the integral of the second derivative is just the first derivative. So this is s prime of t equals minus 32t plus c1. Then when you're going to take again the integral with respect to t, so we're going to integrate this with respect to t. Okay, so we have minus 32 integral of t dt plus c1 integral of dt. And the integral of t is t squared, so minus 32 t squared plus the integral of dt is t, so c1t plus c2. And the integral of the first derivative is the original function, so this is s of t. Okay, so the original function is actually the solution of the second differential equation. Okay, so for example, determine whether the function is a solution of the differential equation. So what does that question is so what? your given differential equation is y double prime minus y equals 0, and identify whether this one y equals sin x is a solution. So is this a solution? Is this a solution of the DE? So ang DE ito lang ng short for differential equation. Then question mark. Okay, so we're going to check whether this function is a solution of the given differential equation y double prime minus y equals 0. So ang nakadiri sa atong differential equation is second order. So we are going to take the second derivative of your y. So the first derivative is given by cosine of x, while the second derivative is given by minus sine of x. So your double prime will be minus sine of x minus your y is sine of x. This is equal to minus 2 sine of x, which is not equal to 0. So y equals sine of x is not a solution of the differential equation. Okay, how about this one? Y equals 4e raised to the power of negative x. So is this a solution of the differential equation? So let us check. No, just look for the second derivative of your function. The first derivative is given by minus 4e raised to the power of negative x. So the second derivative is given by 4e raised to the power of negative x. So we have your y prime. So 4e raised to the power of negative x minus 4e raised to the power of negative x, and that is equal to 0. So therefore, y equals 4e raised to the power of negative x is a solution of the differential equation. Okay, about the third one, for letter C, we have y equals c e raised to the power of x. So the first derivative is c e raised to the power of x, while the second derivative is still c e raised to the power of positive x. Okay, so therefore, c e raised to the power of x minus c e raised to the power of x, that is equal to 0. So therefore, y equals c e raised to the power of x is a solution of the differential equation. Okay. So you can check the solution in this PDF. So you can actually check here that the first one is not a solution, the second is a solution, and the third is also a solution. For this is given for any value of c. So that's how you are going to verify whether a given function is a solution of the DE. Okay. So geometrically, the general solution of first order differential equation represents a family of curves. And this family of curves is known as the solution curves. As an example, we have this one. You can verify that every function of the form y equals cx, c over x, is a solution of this differential equation. So let us first verify. Let's first verify that one. the the differential equation is x y prime plus y equals 0, while the given function is y equals c all over x. So simply take the first derivative, no? Okay, this is the only variable na first order linear naman siya. So, kausaran nimo kuhaon ang derivative niya. So, this implies that y prime is equal to negative c all over x squared. No? So, minus c all over x squared. And so, this is x times minus c all over x squared plus your y, which is c all over x equals, makancel ang usa ka x diri, no? So this is minus c all over x plus c all over x, and that is equal to 0. So therefore, this one is a solution to the given differential equation. Okay, so we have verified now that this is a solution. And then, as said here, the general solution is, or the general solution represents a family of curves known as the solution curves. So if this is our general solution, as you can see, for any value of c, there is a specific graph or curve. Like for example, when c is equal to 1, so you will obtain y equals 1 all over x. So this is the graph of y 1 over x. Meaning black o dark graph. So muna ang graph sa equation basta na kay y equals 1 all over x. And if ang ato ang c is 2, you'll have y equals 2 over x. And ang graph ana niya is kini ang gray graph. Okay, kung negative po ng values ni c, then you will obtain another graph. And since c can be any values, any real number, so you will actually obtain a lot of graph area if you are going to graph this general solution. Okay, so again, it represents a family of curves. Like kung imo ning increase ang imong value ni c, then magtika dako po ang imong graph area. Ang todo ang padung diri. Then napod ka padung diri sa tulos. Okay? So, particular solutions with differential equations are obtained from initial conditions that give the values of the dependent variable, one or more of its derivatives, for particular values of the dependent variable. So the term initial condition stems from the fact that often in problems involving time, the value of the dependent variable or one of its derivative is known as the initial time. So it is the value of the dependent variable when t is equal to 0. And for example, this equation, so this is the acceleration due to gravity. And we can actually have an initial condition given by this one. So at time is equal to 0, the position of the object is at 80 feet. Then at time is equal to 0, the speed, this is the velocity, the first derivative is the velocity. So the velocity of the object is given by 64. Okay, so given this one, the initial values will obtain for the values of C1 and C2. So nakuha diri nga si C1 is equal to 64 and C2 is equal to 80. So this is now a particular solution of this differential equation. This is the given differential equation. This one is the general solution because we do not yet get the values for this constant C1 and C2. So kung nakabantay mo no nga integrate ninyo sa ito ang problems involving integration, especially during indefinite integrals, you will add always plus c because C is constant. So this is actually what we are doing here. Whenever you are going to integrate, there is always a C, or the constant of integration. Okay, so how do we find a particular solution? So let's have this example. For the differential equation given by this, verify that y equals cx cubed is a solution, and find a particular solution determined by the initial condition. Okay, so let us check. Finding a particular solution. So you are given the dE, which is xy squared minus 3y equals 0. The general solution, you have to verify that y equals cx cubed is a solution, and then initial condition IC is given by 2 minus 3 then 2. Okay, so first we're going to verify. This is first order linear dE, so just take the first derivative of the given function. So y equals cx cubed. Y prime is equal to 3cx squared. Okay, and then so this is x times y prime 3cx squared minus 3 times cx cubed. This is equal to, this one is 3cx cubed minus 3cx cubed, that is equal to 0. Okay, so therefore y equals cx cubed is a solution of the dE xy prime minus 3y equals 0. Okay, then find a particular solution given the initial condition minus 3, 2. So minus 3, this is when x is equal to negative 3, y is equal to 2. So how do we do that one? We're going to use our general solution. So at minus 3, 2, we have 2 equals c, your x is minus 3, and then cube. So this is 2 equals c times minus 27. So this implies that c is equal to minus 2 all over 27. Okay, so therefore the particular solution is y equals minus 2 all over 27 x cubed. Okay, so let us check whether this is correct. Yeah, so this is the particular solution given the initial condition. If you have a different initial condition, then you will also obtain a different particular solution, because your particular solution will depend on your initial condition. Okay, so whenever you are asked to find a particular solution, there must be a given initial condition. Para na. Okay, now for the slope fields, solving differential equation analytically can be difficult or even impossible. So, kung gamiton lang na to atong kamot sa pag-solve sa differential equation, medyo lisod na siya. So, however, there is a graphical approach you can use to learn a lot about the solution of the differential equation. And actually, this graphical approach is dili po na siya frequently used no, in solving differential equations, especially kung hand method or ato ang gamiton like manual solutions or analytic solutions. Dili kaayo magamit ang graph method. Ang graph method, magamit na siya if na kay mga computer simulations na buhaton. So, mas dali man i-graph using computers rather than ikaw mismo ang mag-graph sa slope fields. Okay, like for example, this one, if you are going to graph this by hand, medyo lisod na. Possible po no nga dili magka-the same ang lines na to, magtikahiwi ang lines na to because we just have to approximate the lines by the given slope of the differential equation. So, by hand, medyo lisod siya gamiton. So, usually, magamit siya if nanakay mga computer simulations. Dali na siya makuha. Okay. Pero, this is still very important. So, we're going to include this one. Okay, so consider this differential equation given by this form, y prime equals f xy. So it is in terms of the variable x and y. So at each point xy, the xy plane, f is defined and the differential equation determines the slope. We know that the derivative of a function is the slope of the graph of the function at the specific point. So therefore, at xy, we can actually find the slope of the differential equation. Okay, so y prime of the solution at that point. So if you draw short line segments with slope f, xy, and selected points xy in the domain of f, then these line segments form a slope field. So if maghatag lang kang mga values, no, ni x ug ni y, and then imo i-draw ang line segment nga ma-form nimo, given the slope, then ang imo ma-form na graph is the slope field. Slope field ang tawag na niya, or direction field. So, dali na to actually makita kung unsay porma sa imong solutions. Kini sila. So, kini A na to. Makita na to na ang solution sa differential equation is inani ang form, man ang graph niya. Or kung inani man gani, possibly padong siya diri or padong siya diri, depending kung sa iyang initial condition. And also we have for letter C, padong siya taas or padong siya sa ubos or pwede po niya sa kinira siya, no? Sa line, sa horizontal line. Y equals 0 ang solution. Okay, so how do we do the slope fields? How do we form the slope fields? Given y prime equals x minus y. So we are going to plot these points, negative 1, 1, 0, 1, and 1, 1. Identify the slope of the solution given by these points. So at negative 1, 1, if you are going to substitute, your x here is negative 1, your y is 1. We have minus 1, minus 1, so you have minus 2. So this minus 2 is the slope of the solution. Okay? So minus 2, that means negative. So kung negative ang slope, just a reminder, no, kung negative ang slope, paubos siya. Kung positive ang slope, pataas na siya. Okay, so yeah, depende po na, no, kung unsa po iyang inclination with respect to the x-axis. Like kung positive ang slope, no, pwede man nga pana siya or ana or slant pa jud, or pwede po niya mas ubos pa siya kaay, no. So, um, kung ang imong ganing value is dool sa zero, di ba, we know that the slope, kung ang slope is zero, then it is a horizontal line. So kung dool gani sa zero ang imong value, then dool pud sa horizontal line ang imong graph. Pero kung dako gani imong value like 2 or 3, more on the vertical line ang imong graph. So diri asa ito ang graph. So negative 2. So at negative 1, 1. Sama ng negative 1. Okay, negative 1, 1. So this is negative 1, 1. Okay, so tanang kita ano na ang slope niya is paubos. And since 2 man siya, medyo na pang iyang value, layo na siya kayo sa horizontal line. The other one is at 0, 1, and solving the DE, we have negative 1 as the slope. So still negative 1, paubos gihapon. Pero ang inclination niya is mas higda siya compared sa the other one. Okay? This is negative 1, close to 0 man siya compared with negative 2 diri. And also, at 1, 1, the slope is 0. So, this is 1, then 1. Slope is 0, that means it is a horizontal line. Okay, so this is the partial of the slope field. Actually, you have to draw other points like that. 1, 0, 1, 2, 0, 2, 1, 2, 2, 1, 2, negative 1, 2, and so on. So, daghan yung mga points na kailangan niyo slope para ma-draw dyan ninyo ang slope field. Okay? Sige. Pero, ang problem with ani is medyo daghan kay ka o computations. Like, for example, na if you have decimal points, this man pag-identify kung asa dapitan mga decimal points diriya, like if you have 0.75 or 0.70, asa na siya dapitan diri sa graph. So, mga sa nga mga values. Whole numbers lang ato ang ano. And also, I will not require you to draw the slope field of a given differential equation. Pero, I will require you to identify which slope field corresponds to a solution of a differential equation. So, inana lang, no? So, you are given a slope field, and then what is the solution of that differential equation given the slope field? Dili na mo kinahanglan nga mag-draw pa ani nga slope field kay siguro better ang approximations kung gamit ka og computer simulations in drawing or in graphing the slope field that given of a given differential equation. Okay, so example number 4. Match each slope field with its differential equation. So, kini. So, walang kita gawa ng solution. Asa man kahaani ang solutions? Kining letter A. Asa man ani ang iyang differential equation. So, ato sa mga whole numbers, mga dali ra ma-identify ng mga numbers. Like, for example, this one. At y-axis, all of the slopes are 0. That means whatever your y, the slope is always equal to 0, or sa iba ko interpretation. X and y, whatever your y is, x is always equal to 0, because the slope is equal to 0. So kung tanaw na to diri sa ato mga options, your y prime equals x is this one. This represents this differential equation y prime equals x because, for example, in this point here, kini, this, not that one, kini lamang kayo. I think this is 0, 1. So, at 0, 1, kung ato na i-substitute ang 0, 1 diri, ang extra metong tanahon which is equal to 0. So, 0 ang differential equation. And then, at 0, negative 1, or gyapon 0 gyapon si x. Okay, so ang letter A, kini ang iyang differential equation. Ang letter B, sa may mga maayo diri nga mga points tan-aw na to. Letter B, wala. May mga points under. We have it here. Natay 0, no? This is a horizontal line. And this is at 1/2, negative 1/2. Where else? Kini, at 1, negative 1, 1, the slope is 0. So, negative 1, 1, slope is 0. Kini na siya. Negative 1 plus 1 is equal to 0. So, y prime is 0. And then, diri upod at negative, positive 1/2, 1/2, 0 po siya. Diri pod, negative 1/2, 1/2, 0. At 1, negative 1, 0 dapat. So, this is the differential equation. So, naman na siya. So, kung atong tanaw, no, this is for B, no, the second slope field. At 1, negative 1, y prime is equal to 0. At negative 1, 1, y prime is also equal to 0, and so on. Okay, so our option for the differential equations is this one. Y prime equals x plus y. Y prime equals x. Manaman din yung y equals x. Ano naman siya? Y prime equals y. Okay. So, kung ato ni siyang i-substitute diri, you'll obtain 0. Kinipod, kung ato i-substitute diri, you will obtain 0. Pero kung kini, ato i-substitute diri, dili ka makuha og 0. Kinipod, ato i-substitute diha, dili po ka makuha diha og 0. So, dili, ang katong slope field is kini ang iyang i-represent nga differential equation, not this one. Okay? So, for letter B, the differential equation is y prime equals x plus y. Now, lastly, for letter C, well, tanaw na to, no, at the horizontal line, the graph is 0 or the slope is 0. So, at any point diri, y is always equal to 0. So, diri, punish ang differential equation. So, pare-pareha ra C ug ang A, pero kung atong tanaw ko lahi ang iyang graph, kay kung when you are going to integrate this or solve this one, solve na natin si x plus y. Now, for x plus y, dili pa nato siya masolve, pero we can solve the other. Dili po din masolve. So, ato rang masolve is si y prime equals x. So, integrate this y prime, dx equals, integrate dx. So, this is your y and this x squared all over 2. So, kung atong tanaw, this is a parabola and muna siya ang graph sa first. So, ang solution na is a parabola. Then, ang graph sa parabola is something like this. Open up parabola. have some explanations here for the slope field. Sketching a solution using a slope field. Think kaya na siya. So y prime is equal to 2x plus y, and you are given an initial condition, so you have to identify the graph of that solutions. So man sa exam karon ini ang graphing, no? No, possible yan. Possible, but you have to print the PDF para makagraph, no? Okay, so let's solve this one. Okay, so in graphing the slope, you'll just have to identify points closer to the origin. So tanaw diri ako to siya 2 ang iyang values diri. So at -2, -1, asa man na siya dapat kini, the value is -5. So medyo vertical na ang iyang graph. Then at -2, 1. -2, 1. You have -3. So kini siya -3. -1, -1. -1, kini siya -3 gihapon. -1, 1, -1, 1. We have -1. So medyo slant na siya, no? Okay, -1 naman siya. And at 0, -1. 0, -1. Kini. Positive na lagi. No, pero tapos 0, -1, negative gihapon na. So, then at 0, 1, positive na ang slope. So, saka na siya na mataas na ang iyang slope. 1, -1. 1, -1, kini. So, positive gihapon, and so on. Okay, then the solution passes through this point 1, 1. Then kung atong tanda ng 1, 1, mo di siya nga point 1, 1, or kini siyang point, kini mo niya 1, 1. So in graphing the solution, so like this say diri after the slope field is drawn, start at the initial point 1, 1 and move to the right in the direction of the line segment. So kung sa direction sa line segments, kini mga blue diri wala ang imong i-follow pa daw dito. So continue to draw the solution curve so that it moves parallel to the nearby line segments. So kini siya nga line, dapat parallel siya sa kini nga slope. Kini pud nga slope or kini nga slope or kini nga slope. Or kung lagi di siya magian pod nga slope, then musubay ka na. Okay, so pwede gapon pa dong sa left. Kini siya pa dong sa left. Kurakan. Kini siya nga point, di ba? 1, 1. So parallel siya ani o kini nga point, pero moagi siya sa kini nga point. So mo draw ka dara ana. Okay? And then saka na po ka agi na po ka ani. Delete siya mo parallel na siya. Then nadong na siya saka. Okay? So that is the slope field. Dili ta mag-draw ani nga mga slope field sa akin. Dako siya kay mga trabaho. Okay, also most of the exercises given in this PDF, you are not required to draw the slope field. Just you are required to identify the solution given the slope field. Pero dili jud ingon nga kamo jud maghimo ni slope field. So still you have to know how to get this graph, no? Especially this one. You are given the initial condition and what is the particular solution. So this is now the particular solution of the differential equation, and kini mga graph na ma-form ninyo mga particular solutions na siya. Okay. So Euler's method, this is a numerical approach in approximating a particular solution of a differential equation. Okay, I think you can read Euler's method sa previous sections sa numerical analysis sa itong part, no? Sa integration gihapon to, I think wala din ako siya na-include pag-discuss last sem sa ato ang calculus 1. Kay to wala siya part sa calculus 2 pero included man tayo siya diri and this is also very important. Euler's method. This is a way in approximating the solution of a differential equation. Okay, so Euler's method is a numerical approach to approximating the particular solution of the differential equation y equals fxy that passes through the point x naught y naught. So you are given always an initial condition. So from the given information, you know that the graph of the solution passes through the point x naught y naught and has a slope of x naught y naught. So, diba ka ang slope? Diba ka slope, no? Given that you have this point. So, this gives you a starting point for approximating the solution. For example, now in this graph, we have here the starting point, x naught, y naught, and we know that this is the slope. So, after that one, you can actually approximate the rest of the solution. And approximating that is given by these steps. So first, you are given x naught, y naught, and then solve for x1, y1. Kini siya nga point given by this. So x1 is equal to x naught plus h, and y naught, y1 is equal to y naught plus h times f of x naught, y naught. Okay, mali siya ang pag-solve sa y1 and then pag-solve po sa x2 sa y2, the same process pero the same process lang din happen. So x2 is equal to x1 plus h, then y2 is equal to y1 plus h times f of x1, y1, and so on. Okay, where h here is called the time step or step interval siguro. If it involves time, then it is a time step. Pero other than time, siguro we're going to call that one as step na lang. Okay, and then you have n. How many approximations that you are going to include in your solution. Wala siya ang n na variable area. Okay, so let's try solving or approximating the differential equation using Euler's method. So as you can see, we have here the graph and tingnan siguro no, ipili na ito ipakita ang solution and we just compute the solution here. So Euler's method. Y prime equals x minus y. And then it passes through the point 0, 1. And ang step is 0.01. Okay, so this is your x naught, no? This is your x naught. This is your y naught. So we are going to solve for ang sa x 1, this is equal to x naught plus h or 0.1. No, h is 0.1. 0.1 and then your x2 is equal to x1 plus 0.1. Inanara pag kuha sa ato ang x values. So, pila man eh. So, this is 0.1. This is 0.1 plus 0.1, which is 0.2. And x3 is x2 plus 0.1. So, this is 0.2 plus 0.1. That is 0.3. Then x4 is x3 plus 0.1 equals 0.3 plus 0.1 equals 0.4. Okay. So, how about the y values? So, y1, the start is y0 plus h times f of x0 y0. So, this is the first value for y. So, pila man na siya. Your y0 is 1. Your h is 0.1. Then your x0, y0, f is 0 minus 1. So, pila man na siya. 1 minus 0.1. Nag-isod mo kung subtract. So, this is 0. Minus 0. Minus ba? Hindi minus plus 0.9. So, ang first na ordered pair after sa 0, 1 is 0.1 o 0.9. So, kung mag-graph ta, straight sa itong graph, no? 0, 1. Man is 0, 1. So, this is your first point. Ang imong second point is at 0.1 and then 0.9. So, kumani siya nga to ang 1 diri, ang 0.1 possibly nara diri. Then, ang 0.9 is nara diri. So, this is your second point. Then, your third point, y2, will be equal to y1 plus h times f of x1 and then y1. So your y2 now is, your y1 is 0.9 plus 0.1 times this one, pero evaluated at x1, y1. So x1 is 0.1 minus 0.9. So, pil naman ni siya, 0.9 plus ito, calculator nili 0.1 times 0.8. 0.08. Pero I think minus na siya. So, this is 0.82. So, asa man nadapitan ng 0.82. Ang next mo nga ordered pair is at 0.2 and 0.82. So, 0.2 siguro na siya diri. 0.82 na siya diri. So, mani ay mo ang next na pair. And then, continue na siya nimo, no? Continue this solution or this process, you'll obtain more points and eventually padong ka sa kini nga graph. So kini nga graph atong makita. So here we have the ordered pairs, or actually we have it here at the table. This is our starting point. 0, 1. So we have here 0, 1, and then as we solve kanina, our next point is 0.1 and 0.9. Then ang ato ang third point is at 0.2 and 0.82. So matotan on this 0.2 and then 0.82 diri. Okay? And then n equals 3, which is our fourth point, will obtain 3.3 and 0.758. So, ito lang i-approximate the RIA. This is your 0.3 and then this point is the 0.75. So, as you can see, the approximate solution is close to the exact solution. Diba? Close siya kaayo. Pero not really the exact solution because kay dili man siya ang exact approximate raman siya. So, how do we obtain the exact solution for this one? Well, we are going to use a smaller step, no? Ang ato ang h, we are going to make this a small one so that you will obtain a closer approximation to the exact solution. If we're going to use h as 0.01, then you will obtain a closer solution here. Or maybe at 0.001, you will have a very close solution to the exact solution. Okay, however, it's very tedious. It needs a lot of works in solving, especially when we are dealing with decimal numbers. Mas prone to errors ang ato ang solution. Okay? So, now, though we do not have the equation, we only have the graph of the solution, but we do not have the equation. So, in order to find the equation, we are going to use other methods like again simulations. You are going to simulate the points in order to approximate the solution. Okay. So in your case, if you are asked to approximate the solution of the differential equation using Euler's method, you just have to provide these points, no? X sub n up to x sub n, y sub n, kung pila na ka n ang gamitin. And then that is actually the solution of the differential equation. Okay, or approximate solution of the differential equation. Okay, but if nag-require ganing a graph ang approximation, then i-graph ko na to ang approximate solution. Okay, so that's Euler's method and how we are going to use Euler's method in approximating the solution of the differential equation. Okay, and I guess that's it for this video. Also, the exact solution is given by this one. Y equals x minus 1 plus 2 e raised to the power of negative x. This graph is given by this function. So, dili dyan na to siya ma-solve equation kung points ra ito ang gamiton. Okay. Anyways, in higher studies, kini nga mga points kung ato siyang i-plot diri dali ra kayo ang pag-solve sa equation. So, what is the equation given by these points? Dali ra kayo na siya i-solve. Okay? Okay, so I think that's all for this video and see you on the next video.